All right, so here is another practice problem of doing a limiting reagent problem. And so let's go and approach this problem together. So our first step is to always balance our chemical equation. So we balance the chemical equation. In this case, it's a really simple one. We have 1, 1, 2, 1 as our coefficients in our balanced chemical equation. Step 2 is always to go between the compounds. And so we have two different compounds. We have grams of Li2CO3. We have grams of BeBr2. And so what I'll do is I'm actually going to combine all the steps together. I'm just going to write them out over here, and so that you can kind of follow along with these simplified steps, right? And so step 2 is always going from grams of our compound. So in this case, it'll be grams of Li2CO3 to then moles of Li2CO3. And then our third step is to go from moles of Li2CO3 to then moles of our compound that we care about, which is LiBr. And then our final step here in this first half is to go from moles of LiBr to then grams of LiBr. And so what I like to do is combine all the steps together so you can kind of follow along. So our first step is that we're given 29.56 grams of Li2CO3. And our first step, or step 2, is to go from grams to moles. And so we need to know the molar mass of this compound. So I'm going to write a list of molar masses over here. So we have molar masses. And so our first compound that we care about is Li2CO3. And that is equal to 73.89. So 73.89 grams per mole. And so our first step here is to go from grams to moles. And so we have 1 mole of Li2CO3 for every 73.89 grams of Li2CO3. Then our next step is to go from moles to moles. And so we want to find a ratio to get us between moles of these compounds. And so what we have up here is what we want down here, moles of Li2CO3. And we want moles of LiBr. So that's what we put up here, right? A quick way to make sure that you always know what's going to be the ratio is whatever unit we have over here is the unit that goes down here. So once again, over here, grams is a unit, so we want grams down here. And so we now have to use the ratio from our balanced chemical equation. We know that the ratio is 1 to 2, and so we write it as 2 over 1. And then finally, our last step is to go from moles to grams. And so we go from moles to grams. And since we have units down here, we want moles down here. And so we want grams up here. And so we need to know the molar mass of LiBr. And that is equal to 86.84 per mole, right? And so then what we can do is plug that here. So this is going to be 86.84 grams over 1 mole. And if we do all this correctly together, we could do the math, which is 29.56 divided by 73.89 times 2 times 86.84. And you should get a value of 69.47 grams of LiBr, right? And that's the end of our first half. Then the second half is just doing this once again. So I'll color coordinate. I like to do it in the steps 5. So step 5 is go from grams of our other compound. So this is going to be BeBr2. So BeBr2 to moles of BeBr2. Step 6 is to go from moles of BeBr2 to then moles of LiBr2 or LiBr. And then lastly, our last step is to go from step 7, which is moles of LiBr, to then mole or grams of LiBr. And so in this step, we need to know the molar mass of BeBr2. So we need to know the molar mass of BeBr2, and that is equal to 168.81 grams per mole. And so we have to use that for step 5 down here. I'll write this down here. So we start off with our given value, which is 33.762 grams of BeBr2. And we use the molar mass to go from grams to moles. And so we write this as, remember, grams is down here. So you want grams of BeBr2 over one mole. Actually, I'm going to rewrite that over a little further. BR2, 1 mole of BeBr2 over our value, which is 168.81 grams of BeBr2. Then our next step is to go from moles to moles. And so this is by using the ratio from our balanced chemical equation. And so in this case, it will be moles of BeBr2 on the bottom, and then moles of LiBr on top. And that ratio is 1 to 2, and so this would be 2 over 1. And then lastly, our final step is the exact same thing as last time, which is go from moles to grams. And so we have our molar mass of 86.84 grams of LiBr over 1 mole of LiBr. Once again, units cancel each other out and go to the bottom. And if you do this math together or all together, so you get 33.762 divided by 168.81 times 2 times 86.84, you should get a value of 34.74 grams of LiBr, right? And then remember, the way we know that it's a limiting reagent problem or the correct answer, it is always the lower of the two values. So the correct answer is always the lower or smaller of the two values. And so in this case, this one right here is our correct answer. And so we describe this as, I'll write this in the middle right here. We'll do this in blue, light blue. And so we see that the compound that gave us the lower result was BeBr2. So we describe BeBr2 is the limiting reagent. And that our final answer is going to be 34.74 grams of LiBr produced from here. And so I like to box this and say that this is our final answer.